Hey Year 10s, today we are doing tree diagrams. So, you know what to do. Leave a gap for that one. I'm going to fill it in for you. Alrighty, so I'm just pretty much going to show you what a tree diagram looks like and how to fill it in. But we can go through the notes. They show the sample space of 2 or more stage experiments. So that means, like I've called it down here, event 1 and event 2. So when you have, for instance, 3 different events, you might roll a dice, then toss a coin, and then pick a counter out of a bucket. They're 3 separate events. So for each of those, for all those events in line, we can draw a tree diagram for it. They show the probabilities of each outcome. So you can draw the sample space at the end of the tree diagram for each possibility, and then you can write their probabilities as well. Now here's an important one. With or without replacement. So with replacement means that, just say we had a bucket with different coloured counters in. Means we pick one, we look at it, we note it down, and then we put it back in. So the probability is the same every time you pick a counter out. But without replacement means that you pick it up, you look at it, and then you put it out to the side. So next time you pick another counter out, the probabilities have all changed because you've got one less of that colour and one less in total. So you've got to be very careful with that. So without replacement, it's a little bit trickier. And you multiply probabilities along the branches. So when you draw a tree diagram, if you get the sample space, you go along the branches, you multiply those probabilities to get the final probability of that event occurring. Anyway, let's just do a quick example here. An easy one. So my first event, I roll a dice. A normal dice has 6 numbers on it, and then I toss a coin. So there's 2 events. There's my first event, and there's my second event. Or up here they called it 2 or more stages. So it's first stage, second stage. Alright, so the importance when you draw a tree diagram. Start here, is spacing it out is essential. So the first one, I roll a dice. So I've got 6 possibilities. So 1, 2, 3, 4, 5, and 6. Now the key is, try and make them all vertical. So I've got, these are my 6 possibilities. 1, 2, 3, 4, 5, and 6. So event 1, I roll a dice, I could get a 1, a 2, a 3, a 4, a 5, or a 6. Excellent. Now event 2 is after I've done that, I toss a coin. So if I got a 1 the first time, my possibilities for event 2 are either a heads or a tails. If I got a 2, I could then get a heads or a tails. If I got a 3, I could get a heads or a tails. 4, heads or tails. A little bit repetitive. Heads, tails. And if I got a 6, I could then get a heads or a tails. Excellent. So you notice how I've tried to keep it all vertical and nice and neat. Sometimes people have it all skewed all over the place. It's very hard to work out the next bit if you do that. Alright, so the next column, that's our tree diagram almost complete. So now we can do a column saying the sample space. So here's our first event. We list down all different possible outcomes. So we've got a 1 and a heads. So you write down a 1 and a heads. We could have got a 1 and a tails. And try to keep them in line as well. We've got a 2 and a heads, 2 and a tails. We've got a 3 and a heads, a 3 and a tails, 4 and a heads, 4 tails, 5 heads, 5 tails, 6 heads, 6 tails. Excellent. So that's our sample space. They're all the possible outcomes we could get. Now we have to work out the probabilities. So I haven't filled it in on this tree diagram yet, but since there's 6 possible outcomes and they've all got equally likely chance of occurring, I can write in there, each one of these has a 1/6 probability. So we write them as fractions. Always write them as fractions, it's much easier. So 1/6. And getting a heads or a tail, it's a half. So I've got a half of a chance of getting heads or half a tail. So for each of these branches, I can write in a half. And do that the whole way down. Alright. Now one thing to note is that if you look at all these probabilities here, so all the possible outcomes, they add up to in this first event, they add up to 1. And for each one of these, they add up to 1 as well. So that's you've got to make sure you do that. Okay, now the probabilities of the first one of getting a 1 and a heads. It's 1/6 times by a half. Can you see that? We follow that branch up and then that branch across there, and you multiply those probabilities. So the probability is 1/6 times 1/2, and if you know fractions, that's 1/12. So we've got a 1/12 chance of getting a 1 and then a heads. Alright, and you do that the whole way, and it's all the same. So it's 1/12, 1/12, 1/12, 1/12, all the way down. Excellent. And the total down there, if you add them all up, should be 12/12, which is 1. And that's exactly what you want for that. And that's pretty much it. So that's the first example. Alrighty. Now let's have a look at the next one. So it gets a little bit harder now. So box A contains 2 red and 2 green counters, or whatever they are. It doesn't really matter what they are. So let me just draw that. So box A has 2 red and 2 green. So whatever works for you. If this makes it easier, draw a little diagram first. Box B contains 1 red, so 1 red, and 3 green marbles, or whatever they are. Excellent. So that's our situation there. A box is selected at random, and then a counter is selected. So we either pick A or B randomly, and then we have to pick one counter out of them. The first one says, if box A is chosen, find the probability that a red is chosen. So this is like conditional probability. The condition, it's saying that box A is chosen. So we don't worry about box B at all. So if box A is chosen, so we're just looking at A this time, and you've already done an exercise on this. Find the probability that a red is chosen. So we have 2 reds out of 4 in total. So the answer is 2 out of 4, which is a half. See that? Because we're just looking at box A. It's conditional probability. So it's the same as saying, find the probability of a red. So remember that. Find the probability of a red given that box A is chosen. So you should have done that from a previous exercise. But you don't have to do that now. It's just I'm showing you that's what it could say. Next one, if box B is chosen, find the probability that a red is chosen. There's box B. So we don't look at A at all. A red is 1 in 4. So that's the answer. It's just 1/4. So that was easy. And again, this is conditional probability. You could have written it like, find the probability that a red is chosen, given that box B is already chosen. See? So and you've done that before. But you don't need to worry about that, just do it this simple way. Excellent, now draw a tree diagram. So, we've got box A and box B. So we start down here. So we've got box A and box B. And then, if we pick box A, what are the possibilities? We've got 2 reds and 2 greens. So you only have to don't write red twice. The possibilities are red or green. And the next one, if we pick box B, our possibilities, again, are red or green. And that's it. We'll put the probabilities in just in a minute. Okay, now our sample space. Our sample space, remember that? We can get box A and red. So it could be A red, it could be A and then green. It could be B red, or it could be B and then green. And then we put the probabilities in. This is our last column, the probabilities. Now the probabilities of getting A or B is half and half. There's no more likelihood of getting A or B. There's just equal chance. Now if we picked A, probability of getting a red is 2 out of 4, or a half, and green is 2 out of 4, or a half. So I'm going to leave it as quarters now. I'm not going to simplify, and it will become obvious in a minute. And now the next one, if we pick box B, probability of a red is 1/4, and probability of green is 3/4. Alrighty, and now we can work out our probabilities over here. So remember, you multiply them. So this one's a half times 2/4. So I'll do the first one for you. A half times 2/4 is 2 over 8, which simplifies to a quarter, but for now I'm going to leave them as eighths. And I'll show you in a minute, because when we answer questions, and you might have to add them together, it's easier if they're all eighths. So a half times 2/4 again. A half times 2/4. See there, half times 2/4, which is 2/8 again. The next one, a half times 1/4, which is 1/8. And the next one is a half times 3/4, which is 3/8. Now, a good thing, we've finished that now. A good thing to check is that our totals, 2/8 plus 2/8 is 4/8, and 1 is 5/8, and 3 is 8/8. So we've accounted for all the possibilities. 8/8 is 1. So one of those events must happen, and it equals 1. It must be certain that something's going to happen. And there's our tree diagram, everyone. So again, remember that these add to 1, so half and a half, and these two add to 1, and also those. So you can just check that. And remember, to get your probabilities, you multiply along the branches. Excellent. Now let's do the last couple of questions. Find the probability of selecting box B and a red. So now we just have to look along here. Which one's box B and a red? So box B and a red is there. The probability is 1/8. So you just select from the answers down there. Find the probability of selecting a red counter. Alright, so this time, which ones are red counters? We've got here, we've selected a red counter, and also this one again. We've got box A and a red, or box B and a red. It doesn't specify which box you picked it from. So the answer for this one is 2/8 plus 1/8, which is 3/8. So you have 3/8 of a chance. If you picked a counter out, you've got 3/8 of a chance of picking out a red counter. And that is pretty much it for now. So I'm going to do another couple of examples in a minute. See you soon. Hi Year 10, welcome back. Okay, so this time we're going to do another example. I won't let you copy it now. I'm going to go through it with you, and then I'll let you copy it all at the end. So the last example we just did was with replacement. So when something is with replacement, like you take a marble out, look at it, and put it back in, that means that the events are completely independent of each other. So if I picked a green marble out the first time, put it back in, and then I look at it, and then I pick another marble out, the second choice that I pick is completely independent of the first one, because the probabilities aren't going to change. But this time, if we read the question carefully, a bag contains 5 blue and 3 white marbles. So I'm going to underline the important bits. 2 marbles, so 2 marbles are selected, so that means there's 2 events, without replacement. So that means what we do is we pick one marble out, we look at it, and we put it to the side. Then we pick another one out, but like I mentioned a minute ago, all the probabilities are going to change, because at the start there's 8 marbles in the bucket, or in the bag, and then once we've picked one out, there's only 7 left. So this is actually the dependent events in this case. You're going to learn about this next lesson. I'm just preempting what you're going to learn next lesson. But anyway, draw a tree diagram of the situation. Alright, so our first event. So what options do we have? We could get a blue or a white. So that's pretty easy. There's just 2 options. Make it nice and big, blue and white. And that's my first event. So I'm going to write that like that. See, nice and vertical. It's really hard to get it nice and neat, you've got to practice. Okay, now the second event, if we pick the blue, we can pick a blue and a white again. So not many options there, just blue and white. And if we've got a white, we can still get a blue or a white. So that's the shape of our tree diagram, that's our second event. See, it's nice and vertical, so I've done a good job. Thanks. Alright, and we do our next column, which is sample space. And then our next column is probabilities. So we always do that, just so we can answer all the questions at the end. Alright, now let's have a look, put some probabilities in. We have 5 blue and 3 white. So what's the probability of picking a blue one out? We have 5 chances out of 8, so it's 5/8. And picking a white, we have 3 out of 8, so it's 3/8. And again, add these up together, they add up to 1, 8/8, which is 1. Good job. Now we have to think a little bit. If we pick the blue one out the first time, what's the probability that we're going to pick a blue out again? We did have 5 to start with, but now there's only 4 blues left, because we picked the one blue out and we did not replace it. It's without replacement. So there's only 4 blues left, but we've only got 7. was an interjection of little Timmy in the background who's just got a dumb question. Excellent. Thanks for that. So the next one, a blue and then a white. So if we pick the blue one out, we still have 3 white ones. So we've still got 3 white, but we've still only got 7 because one of them's disappeared. Alright, so let's see if the teacher can do this by himself this time. Alright, so if we pick the white one out, there's still 5 blues. So we've got 5 chances of getting a blue, but there's only 7 in total. We picked a white one out the first time, then there's only 2 whites left. So we've got 2 whites out of 7. So now we've finished our probabilities without little Timmy in the background yelling out, "You've done something wrong," when I haven't. Now we can write sample space. So blue is there. We've picked a blue and then a blue. We've got a blue and a white. We've got a white and a blue. Try to keep them in line if you can. And the last one is a white and a white. Excellent. Now we can do our probabilities. So remember you multiply along the branches. So the first one is 5/8 times by 4/7. And hopefully you know your times tables. 5 4s are 20, 7 8s are 56. So 20 out of 56. Normally we say simplify. And maybe when you answer the question in words, simplify your answer then. But in this tree diagram, I would leave it like 56 because then, yeah, we'll get to that in a minute, you might need to add them together. So the next one is 5/8 times by 3/7. 5 3s are 15, 7 8s are 56. 3/8 times by 5/7, which is 15, 7 8s are 56. Whoops. And the last one, 3/8 times by 2/7, which is 2 3s are 6 over 56. So you notice they're all over 56. The textbook actually simplifies them first, makes it all complicated. So leave them like that. So excellent, we've got our probabilities there. So this is without replacement, remember? And that means that the second event is dependent on the first event. What happens in the first event is going to affect the second event. So that's called, they're dependent on each other. Whereas if I tossed a coin and rolled a dice, those two events are completely independent of each other. Like I said, that's next lesson. Anyway, find the probability of selecting a blue, then a white marble. So a blue-white. So there's a blue and there's a white. There it is there. Blue-white, 15 over 56. And that's your answer. You've already done the hard work. Now it's just a matter of answering the questions. 2 blue marbles. Okay, where's that? Blue, there it is. 2 blue marbles is 20 out of 56. Excellent. And the last one, exactly 1 blue marble. So where do we have exactly 1? That's not exactly 1, that's 2 blues. So there's 1 blue marble, and there's 1 blue marble as well. That's no blue marbles. So it's this one plus this one. So it's 15 out of 56 plus 15 out of 56. You add them together. That's why I left it the same denominator, 56, because then we can add them together nicely. So 15 and 15 is 30 out of 56. So now is a time when you can simplify those if you wanted to, once you've answered the actual questions. Excellent. So there's your homework, exercise 8F, questions 1 to 9, have a go of. So this is, I'll just stress again, it's without replacement. So you're not replacing that first one. If we did it with replacement, if it said the question was with replacement, it'd be the same tree diagram, but it'd be 5/8, 3/8, and then it'd be 5/8, 3/8, 5/8, 3/8 would be the probabilities there, and then you just multiply along the branches again. So these would be slightly different. Excellent. Thanks for that. I'll see you soon. Oh, and copy down the notes. Yes, thank you.